Okay, so when I use 1, which is total probability, minus the probability of A, which is this area over here, I will get probability of A prime, which is everything outside A. Okay, so I think this one should not really have a problem. Okay, maybe we try one question first. In case just to be safe, Okay, let's take a look at this. Okay, I'll be maneuvering between different platforms because I find it more productive to draw it on Microsoft Whiteboard.
Oh.
Okay.
Okay.
Okay. Can see, right?
Yeah.
Big enough. Okay, good. There's another upside to online tuition also lah. You don't have to travel down. And it's at the comfort of your own home.
That's
yeah.
true.
But that is provided if the student, right, is disciplined enough to really be focused. Yeah. Of course, we will have breaks. We will have breaks here and there. Yeah. Okay. Right now. So a dartboard has 36 sectors labeled 1 to 36. So basically, it's like a circle. Okay, it's like a circle. Okay, so it has like a lot of lines. You know, a lot of lines. You seen a dartboard before, right?
Yeah.
Yeah, a lot of lines. So when you throw a dart, it's going to land somewhere. It is going to land somewhere. So I will not be able to show all 36 sectors, but you get the idea. Something like that. Okay?
Yep.
Yeah. So there are 36 sectors in total. Determine the probability that a dart thrown at the center of the board will hit a sector labeled with multiples of, it's a multiple of 4. So this is when we need to understand, okay, what are the multiples of 4, right? Okay, so multiples of 4 is equals to what? Can you write it down for me?
Okay.
Actually,
wait, but if I write, can you see?
Do you use a mouse? Do you use a mouse or use trackpad?
I'm using trackpad.
Because trackpad quite difficult to write. If you use a mouse, easier.
I have a mouse, but then I never put battery inside. Like I'm using the wireless mouse, but then my wireless mouse no more battery. I need to go and like get a battery.
Oh, okay. Then I might I'll write for you first because trackpad quite difficult to write. But on trackpad, still possible to circle things.
Yeah.
Okay. Yeah.
I think the next lesson I just use a mouse because I have a mouse, but it's just like,
okay. The next best alternative, right? The next best alternative, right, is that you use an iPad.
Oh.
Do you have an iPad? No. Okay. That's the next best alternative lah, but don't have, never mind. Don't have, never mind. It's okay. Laptop still okay. Use mouse is possible.
Yeah, okay.
Yeah, because I will be the one that's doing more of the writing. Yeah. Okay. So multiples of 4. So we know that it'll be what? 4,
8. But yeah, 4, 8, 12, 16, 20, 24, 28, 32, and then 36.
Correct. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9. Okay. You can see my mouse moving?
Yes.
If I do this, can you see my mouse moving?
Yeah, but it's a bit slow, but yeah, I can see it moving.
Oh, okay. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9. We have 9 multiples of 4. Okay, so over here, we want to find the probability, right? So this is how presentation is very important. Okay, a lot of people can give me the answer. It's very easy. You use 9 over 36. Right? So you must put P bracket, okay, multiple of 4. Okay, so you have 9 over total number of outcomes, 36. Yeah. So from here, you will get 1
over 4.
over 4. Correct. Okay? Next. Okay. A number between 9 and 6, 6 and 9 inclusive. So how many numbers are there? So it's 6, 7,
8, 9.
9. When they say 6 and 9 inclusive means both 6 and 9 are included, yeah? Yeah, it's not just 9 included, okay? Because some people see it as, between 6 and 9 inclusive means 9 inclusive only. But yeah, both sides. So total we have 4 here. So same thing. Probability of number between 6 and 9 inclusive. Okay, so that will be 4 over 36 again. So it's 1 over 9. Okay? Great. Sure, I can use this instead. Okay, a number greater than 20. Okay, I think, okay, for part C, you should know how to do. D, I think should be fine. Multiple of 13, you also know. Odd number that is a multiple of 3, both multiple of 6, a multiple both 6 and 4, or both. Okay, I think this question is, you more or less will understand what to do here. I think we should try more challenging questions for your level. Okay. Yeah, this is too easy for you. Okay, I think this is what we should be trying. Okay, independent events. Okay, independent events extremely important. Okay, so have you learned this yet? Independent events?
Yes.
Yes,
I have. Yes.
Okay. Do you understand what does it mean to be independent, for both events to be independent?
For both to be independent of one another.
Do you know what does it mean?
What it exactly means, what it means, maybe not, but like when I do it, I
You know how to do it.
Yeah.
Okay, let me explain to you.
Mm.
If I say that, okay, never mind. If I say that A and B are independent events, right? Okay, just think of it this way. Okay, event A is me going to army. This is you going to ACSI, ACS International. Okay, are they independent events? Are they independent events?
Yep.
They are, right? Yeah. There's no effect on one another. When I go to army, you can still go to school. When you go to school, I can still go to army. We do not depend on each other. Right? There's no effect on it. So when two events do not affect each other, they are independent. So what happens when they're independent, okay? Because whatever formulas that you see just now, right, it came from this thing called conditional probability. Okay? You'll see something like probability of A given that B has happened.
Yeah.
So this line that you see here, okay, this straight line that you see here, okay, it means such that, it means given that B has happened.
Oh, okay.
Okay, the probability
Yep.
of A given that B has happened. Okay, when they are not independent, right? Okay, when they are not independent, right? The formula looks like that. A intersect B over probability of B. Okay. If I'm not wrong, this formula is in your formula booklet.
Oh, okay.
Okay. If I'm not wrong, this formula is in your formula booklet. But is it necessary to memorize it? I mean, for my students, I always want them to memorize it. Yeah. So probability of A such that B has happened is probability of A intersect B over probability of B. Remember, I see this line here, right, as like a division. Okay. I see this line here. I see this line here as like a division.
Okay.
Yeah, so that's why I always divide by the event that has already happened. I always divide by the probability of the event that has already happened over here.
So what? So the denominator is always the probability of the event after the line, right?
Yes, you're right.
Okay.
Can? Yeah.
Yep.
So that is a trick to memorize it. You don't have to confuse yourself over this thing.
Okay.
Okay. So now this is for the fact that this event here is for the case where they are not independent.
Okay.
They are not independent. Okay. But when they are independent, okay, when they are independent, what happens is that just imagine probability of me going to army given that you are going to ACS International. We don't affect each other, right? So probability of me going to army given that you going to ACS International is basically probability of me going to army. Make sense to you?
Wait, say again.
Okay, yeah, it's fine. Probability of me going to army,
Yeah.
okay, given that you going to ACS International is equals to the probability of me going to army.
Is it because they're independent events?
Correct. Because they're independent. My probability of going to army does not affect your probability of going to school. Your probability of going to school does not affect my probability of going back to army. That's why the probability of me, okay, so when it's phrased this way, where the probability of me going to army, given that you are going to school, what is it that they want to find out? It's about the probability of me going to army. That is the priority. It's not about you going to ACS International. But in the event where they ask probability of B given A, which one comes first? Yeah.
So it will be like P probability of probability of B intersect A over probability of A, is it?
Yes.
So basically it's just the other way around.
Yeah, but if considering that both are, if B and A are independent events, this will be equals to,
then will be probability of B.
yes. So this whole thing here will be equals to probability of B. Because now the question is concerned about you going to ACS International. The question is no longer concerning about me going to army because we are independent. Yeah. So that is why look at this formula. If I were to manipulate this a bit, I will get probability of B intersect A is equals to probability of B times probability of A.
Oh.
See it? So now if we were to go back to our book, you will see this. Yeah. This is the reason why. Get it?
Okay.
Yep. Yeah. Okay, ma? Okay. Now,
so basically the N thing is when it intersects lah.
Again?
Is it? Because if you see the thing in the book, right, it says like if A and B are independent events, then probability of A and B equals probability of A plus probability of B, right? But then it says when it says probability of A and B, it's like if you draw like a Venn diagram, right? And then like there's the intersection. If it says A and B, that it means like intersection, right?
A and you mean A intersect B? This
Yeah.
one, like wait, like that.
Yeah, is it?
Is it? Yeah, this means intersection. You're right.
Okay.
Which means
so if you were to draw, then you draw A and B, then the intersection lah. Okay.
okay.
Yep.
Just for information, probability of A intersect B is equals to probability of B intersect A. Is the same thing. Okay.
Because it's the same intersection point, ma.
Yeah, exactly. Yeah,
Okay.
you're right. You're right.
Okay. Okay.
Okay. Now, let's see. Let's try question 2. Okay. What you can do is, right, you can do it on your paper. Okay, you can do it on your paper. Then after you're done with it, you can take a snapshot and send to WhatsApp. Then we can discuss. I'll pull it out of WhatsApp.
Okay.
Okay, you try question 2, or rather 1, 2, and 3. 1, 2, and 3.
1, 2, and 3.
Yes.
Okay. Oh man.
I'll go get a cup of water first.
Okay.
Let me know when you're done, yeah?
Yep. How do you do the one where it says like determine the probability that it rains on 3 successive days? So do I just times the do I just like take the answer of B times times like probability of something?
Can you hear me?
Yes.
Okay.
I have a question, for like
Yeah,
1C.
I just now I heard you, but I couldn't. Just now I don't know why I cannot speak. Okay.
Oh.
1C, right?
Yeah.
Okay, let's take a look at this.
Mm.
Oh dear, why can't I? Think controls. Oh, okay. Now I can do it. Share. Okay. At a mountain village, it rains on average 6 days a week. So the probability of raining is 6/7.
Yep.
Okay. So that is for part A on any one day.
Mm.
So for part B, on 2 successive days, rain on 2 successive days. So it'll be 6/7 times
6/7.
6/7. Okay. C. Probability that it rain on 3 successive days. So it will be 6/7 times
6/7
times.
times 6/7 again.
Yeah.
Oh.
Why? The reason why we can keep repeating 6/7, right, is because they are independent. Yeah, we are assuming that it's independent. That today and tomorrow, they are independent days. If it rain today, it doesn't mean that, there will be lesser water in the sky.
Oh.
We are not thinking in that sense, but geographically, it should be that way, right? You know what I mean? Because there'll be lesser rain clouds, then it may not rain tomorrow if it rains today. But in this case, we are assuming that on all days they are independent. That's why we can keep using 6/7. Because if you want to take into the geography into account, right? The with it raining today is 6/7. Tomorrow might be a lower probability already. Yeah. Understand?
Okay. No, like like the second question, right?
The second.
Yeah, the second question. Can you just do like half times half times half?
It is correct.
Oh, okay. I write it out properly first. Am I only supposed to do until question 3, or do I do question 4?
Question 3.
Okay, yeah, then I'm done.
Done.
Yep.
Okay, let's take a look. Can you see the screen?
Yes.
Okay. So question 1 we went through already. Oh dear, oh dear. Okay. Question 2, probability of, part A. Probability of having a head and head and head is half times half times half, right?
Yep.
And probability of getting a tail and head and tail will be half times half times half. Exactly, it's the same thing. Because why? We are assuming that every flip is independent. That's why. Understand?
Yep.
Okay. Okay. So for question 3, a school has 2 photocopiers. On any one day, the machine A has 8% chance of malfunctioning and machine B has 12% chance of malfunctioning. Determine the probability that on any one day, both machines will malfunction. Means, okay, so you have to write it out for part A. Probability of machine A 40 and machine B 40, right? Okay, if your machine A 40 and machine B 40, notice that you use N. Okay, if you use machine A 40 or machine B 40, right? Okay, you will be adding them. You will be adding the 2 probabilities. If you use machine A 40 and machine B 40, means you are talking about intersect. Yeah. If you're talking about OR, if it's an OR,
like union, is it?
yes. Yes. So right over here, it will become probability of, wow, interesting color. Interesting. We use, yeah. So you'll be using probability of machine A 40 times probability of
machine B 40.
Wow, interesting, the color, the gradient. Okay, then we equals to
8/100
times
2/100.
Exactly. So this is the kind of presentation that the markers want to see.
Yeah.
Okay. Then next, for part B, determine the probability that both will work effectively. Okay. So now we want probability of both machines
Working.
Okay, just both machines working. So how are we going to do this?
Must you show like you have to do or can you just do like 92/100, or must you show that it's 1 minus 8/100 equals 92/100? Do you have to do slowly, or can you just go with
Show.
92/100?
Have to show. So because over here, what you want to show is that probability of A working, both machines working means probability of A working and B working, right? So from here, you'll be like, oh, since they are independent of each other, so it will be probability of A working times probability of B working. Right? So it become 92/100 times
88/100.
Yeah, so you go and evaluate. Okay.
Yep.
Okay, there is one thing here that I need to mention is that okay, let me ask you a question. Since for part A is about machine A 40 and machine B 40, right? Can I use total probability, which is 1, minus part A? Because part A mentions that machine A 40 and machine B 40, right?
Yeah.
Yeah. So can I use 1, which is the total probability, minus both machines 40 to get this?
No.
Can I?
No.
Why not? And why? If yes, why yes?
Um, hmm, I know cannot. So I'll say that you can't do that, but um is it because you're talking about both machines like together? Because it's like separate probabilities.
Not exactly. Okay, let me explain to you. Because, can you see my mouse?
Yes.
Okay, because when you use 1 minus part A, okay, you are finding the complementary probability, right?
Yeah.
What is the complementary probability of both machines 40? What is that? What is that one event or events that is in a complementary set? When you use 1 minus both machines 40, definitely you will get both machines working, correct?
Yeah.
Yeah. But are there other probabilities also that
Yeah.
will
Like
constitute this probability?
A can be faulty but B is working, or like the other
Correct.
way.
And the other way around, you're right. Very good. Correct. That's why we cannot use 1 minus the probability that we found in A.
Oh.
Because there are
Oh,
other probabilities
basically because
involved.
there's like other scenarios lah. Like,
Correct.
oh,
Correct.
okay.
Understand, huh?
Yeah.
Can. So, I think this is also good practice. Okay, let me see. How much more do we have? Okay, I think next we will probably be moving on to 3 diagrams already.
Okay.
You want to take 5 before we move on, or
Still can go. Yeah.
you can?
Yep.
Okay. Okay. Now we're moving. Just now was independent events, right? Yeah. Now we're moving on to dependent events.
Okay.
Okay. So if they are dependent, means they are not independent.
Yeah.
Right? So they affect each other.
Yep.
So when both events affect each other, the sequence of the events matter.
Yep.
The sequence of the events will affect the probability of each event happening. You understand what I'm trying to say? Like, let's say you're talking about raining just now. Okay, we're talking about raining. So if it rains today, what's the probability of it raining tomorrow? I mean, if you factor in the geography of the place, tomorrow will be
Then
lower, right?
then there'll be like less rain lah.
Yeah,
But
less rain, or it may not rain, right?
yeah.
Yeah, because now we are talking about if both events are dependent. If it's independent, the probability will never, ever, ever change. Okay, because it's independent, right? If it's dependent, definitely once it affects the other event, the probability will decrease or increase. We don't know. Okay, we have to look at the question to find out. Okay. Hello. Yeah.
Yes,
So
yes,
now,
yes.
if you look at this part, dependent events. Suppose a hat contains 5 red and 3 blue tickets. Okay, there's a hat, and inside there are 5 red and 3 blue. One ticket is chosen randomly. Okay, its color is noted, and then it is put aside and not put into the hat. Means what? Means this part is trying to tell me that this part, can I use, yeah, I can use this. It's noted.
Ooh.
And then it's put aside and not put back into the head. Okay, this is the highlighter function that I was talking about.
Okay.
Okay, so this is talking about that it is it is without replacement.
Mm.
You get what I mean? Means they are not going to replace it. So once you take out one blue or one red, right, the probability of getting a red and probability of getting a blue will be different already.
Yep.
Okay, and okay, so let's proceed with understanding the question. A second ticket is then randomly selected. What's the chance that it is red? Okay, so over here, if the first ticket was red, the probability that the second is red will be 4/7.
Mm.
Do you know why?
Yeah, cause originally got 8 ma. Then when you take out the first one, there's only 7 left inside.
Okay.
Then since there's 7 left inside, that means there's 4 red and 3 blue ma. But then so if you want to pick the second one, if the second one, the probability of the second one being red is like 4, because there's 4 reds inside ma. Then 4/7 inside the hat.
Okay, so if you can explain to me the first one, I think you can explain to me for this case also lah. So let's not go to that already.
Yeah.
Okay, nice. Okay, so with that said, we just try one question from here or two. Then after that, we can go to 3 diagrams, which was what you were talking about earlier.
Yep.
Then after which, do sampling with or without replacement. Sets and band, maybe sets and band diagrams, we might not need to do that lah. This one is, we will see how fast this one. Yeah, my display. Okay, we just try one question from there. Hold on, let me choose a question. Yeah, we try two lah.
Question 2 So I do this now the question 2.
Yeah. Can see or not?
Yeah, can.
It's on the whiteboard now, right?
Yes.
Good.
Two balls are drawn one after another. So meaning you draw one ball out first, then after that you draw the second one, is it?
Yes.
Yeah. So it means you take one out first,
not
then you
together.
take the...
Yes. It's not together.
Okay. Okay, done.
Okay.
That's question 2, right?
Yeah, question 2 and 3.
Oh, okay, wait. I haven't do 3 yet. Wait.
Okay.
Well, I don't quite understand how like they're phrasing the question, like the question 3.
Okay, wait. Let's see. A lottery tickets. Okay, a lottery has 100 tickets. 3 tickets are drawn from random without replacement. Very important key point. Without replacement. To decide 3 prizes. Okay. If John has 3 tickets in the lottery, determine his probability of winning the first prize. Okay. So out of these 100 tickets, right, there are 3 tickets that belongs to John. Okay. So
Yeah.
you need to understand what's his probability of winning the first prize.
Does that mean it's 99 out of 100?
Huh? How is that possible?
Because like they say,
He
but
has
they say they're also it doesn't mean does they're taken out one by one, right?
yeah, he has 3 tickets in the lottery. So let's say now it's 100 tickets, right? Okay, so now I'm going to draw 1 ticket. Okay, now I'm going to draw 1 ticket to determine who gets the first prize.
What? Sorry?
Now I'm going to draw 1 ticket to determine who gets the first prize.
Yeah.
Okay, so what's the probability of John winning the first prize?
If you draw 1 ticket out, that means it's it's over 100, right? Because you haven't.
It's over 100, definitely over 100. Okay, so to get the first prize, probability of getting the first prize, okay, it will be 3 over 100.
Oh.
You get it now?
Oh yeah. Okay. Oh, okay.
Yeah.
Brain fart. Wait. 200. So that means if you were to find the probability of him getting the second prize, right? That means it will be is it 2 over 99?
Yeah, for the second prize. Yes.
Right? Yeah. So that means
Because
if you wanna find the answer for B, right? Then that means you just times those two. So 3 over 100 times 2 over 99, right? Okay.
Yes, because you want to get the first and second. They never say first or second.
Yeah. Okay, wait, then I continue doing.
Okay.
Okay, done.
Okay. Let's go. Okay, so first for part A is pretty much done.
Yep.
Use the Galaxy pen.
Cool pen.
B. Okay. First and second prize. So to get the first prize, first and you can see, right?
Yeah, can.
Is it hard to read?
No.
Nice. Probability of first and second prize. So the first prize is 3 over 100, as you already knew. Second prize will be 2
over 99.
89, right? Then for all three prizes, for part C, all three prizes, it will be 3 over 100
times 2 over 99 times 1 over 98.
Yep, very good. None of the prizes will be
97 over 100.
97 over 100.
Is it because you just is it not? Wait.
Let me think.
None
of the prizes. Okay, so probability of
no prize.
none.
No of the prizes.
Okay, so let's say for the first prize, let's say first prize has already been taken. Okay, so it will be 3 over no. Okay, sorry. Hold on.
Yeah.
Okay, let's say first prize. So we want to talk about him not winning it. So it'll be 97 over 100.
Yep.
Yeah, correct. Times
97 over
96 over 99.
How why 96? 97?
Because after one ticket has been taken out, they're only left with 99 tickets, right?
Yeah, no, but why is it 96?
Because there is still three of John's tickets in the lottery. Do you understand what I mean? Out of these 100 tickets, 97, okay, in this first probability, right? Okay, there are 100 tickets.
Yeah.
There are 3 tickets that belong to John. 97 of the tickets do not belong to John.
Yeah.
So if we want John to lose, it will be 97 over 100, correct?
Yeah.
Okay, makes sense. Now we go to, so let's say for the first prize, okay, the MC took out the one of the ticket, or someone won. It wasn't John. Okay, but John know that I still got 3 tickets inside. Right?
Yeah.
Yeah.
So it's still because he hasn't won anything yet lah.
Exactly.
So it's 99 minus 3. Oh, okay.
Yes.
Oh, okay.
Then for the last one will be
95 over 98 times 95 over 98. Okay.
Okay. We haven't gone through question 2, right?
No.
Okay. Okay, a box contains 7 red and 3 green. 2 balls are drawn one after another from the box without replacement. Find the probability that both are red. Okay, so firstly, same thing again, very important point, without replacement. If we want probability to find both red, probability will affect each other. They are dependent events. So once again,
7/10 times 6/9.
So next, for part B, probability that first green, second red.
So it's 3/10 times 7/9.
Probability that green and red obtain. Wow, this one a bit different, huh?
Yeah.
How?
So because the previous question already found the answer for first is green, second is red. Because if you want green, one red, it can mean it can be the green first then the red, or the red first then the green. So it's like two probabilities.
Very good.
So that means like one part of the answer you already found is the answer from part B, right? Which is like 7/30. Because that one is the probability for the first ball green then second ball red. So you need to find the probability for the first ball red then the second ball green, right?
Fantastic. You don't have to tell me your answer already because you got the concept right. Yeah. If you can explain this to me, you means you understood already. But I still, as your tutor, I still need to go through.
Wait. The last part, do you times or plus?
What do you think?
You plus. Wait.
Correct.
Yes,
you plus because you want to have first green, second red, or first red, second green.
First red, second green.
Yeah, because how this is translated, it will be first red, second green, or first green,
second red.
Second red. You're right.
Okay.
Yeah.
Yep.
Okay. So over here, you want first red and second green. Here is times. First green and second red is times, but the or is plus.
Yep. So the probability for the first ball red, second ball green is 7/10 times 3/9. Right?
7/10 times 3/9. Correct.
Then you just plus those two together. So that's the answer. Okay, yes.
Okay, your probability concept's not that bad, honestly. In fact, I think it's quite good. So don't need to worry about probability. But probability is essential for statistics.
Yeah.
Just to let you know. Okay, now we are at 3 diagrams. Okay, as you can see, right, it's called 3 diagrams for a reason. It means you need to draw the 3 diagrams.
Yep.
Right? Okay, I think we jump straight to the question because my time is running out already.
Wait.
Okay. Let's try out question 4 first. Okay, just this question will do. Anyway, this session will be recorded. It will go on to YouTube. Like I have to let you know because you'll be public and people will be able to see this. Yeah. Okay, let's try this.
Okay. Oh, so Matla is a horse. Wing. What does it mean if it is fine?
If it is fine,
What
means
does that
it's
mean?
good lah. If this horse is good, I think so. If it is fine, if it is, no, it's not. Oh my god, what is it?
It's so
I think it's
confusing.
a, I think it's a horse race. I think it's a horse racing term. Man, shit. If it does good, it will start favorite in the horse race. If it is fine, shit, this is a horse racing term. Okay, hold on. Let me check it out.
Yeah, okay. With probability half of mean.
Fine.
Wow, this. If it is fine. Wow, I really don't know.
Never say if it is fine.
Otherwise, you do another question.
Yeah, we do another question.
Okay, do another question.
If it
Yeah,
is
what
fine.
does it mean like if it is fine?
What the heck? That's true.
So what does it mean if it's not fine? I don't know. Change question.
Hey, so your school now has like online learning as well.
Yeah, starting to have as a trial.
Like on once a week
Uh, ours next week we have 2 days just to make sure it works. But then it doesn't follow the Friday thing. Ours is Monday and Thursday.
Oh.
Okay, wait, I do this one now.
Okay.
This one easier to understand now. Determine the probability that the next bottle inspected is spoiled. Hmm. Wait, so how do I go from here? Because I already drew my tree diagram.
Okay. So over here, let's see. You send me a group. You send me a tree diagram.
Okay, wait. Where I'm sending. Looks like that.
What is going on? Okay, 40% of the bottles produced at the factory, machine B makes the rest. Okay, so 40, 60, correct. Machine A spoils 55% of the product, 5% spoiled, 95% intact, good. Spoils only 2%, okay, good. Okay, determine the probability that the next bottle inspected at this factory is spoiled. So this is taking into account for both machines. Okay, taking into account for both machines. So from here, probability that the next bottle inspected at this factory is spoiled. So you have to translate this into a mathematical statement. So it's a probability of, okay, bottle from A but spoiled. Okay, because we want it to be spoiled one. Yeah, let me put a bracket. And then we also want bottle from B and also spoiled. So what's the probability of this happening? So do you think it's an and or or?
This one is,
because okay, it's easy to find bottle from A spoiled. The probability is really from here, then go to here, right?
yeah.
Yeah. Bottle from B, it will be from here, then spoiled, you go to here.
Yeah.
Yeah. But the question to ask now is, do we want bottle from A spoiled or bottle from B spoiled, or bottle from A spoiled and bottle from B spoiled?
Is it all?
I'm still trying to reason it out. Bottle from A spoiled or bottle from B spoiled? I think it's all here, right? Should be all. Yeah, because if you're talking about the next bottle, right? It's only
I mean,
one bottle.
they never say it has to be from A. They never say it has to be from B. So it's probably all.
Yeah, it has to be all, you're right. So it's
Yes.
very simple, right? So over here, to find the probability is simple. It's just 2 over 5 times
1 over 20.
Yeah. Plus 3 over
Plus
5.
3 over 5 times 1 over 50.
Yeah, that's all.
Oh.
Can?
Yes.
Okay. Your teacher stopped at 3 diagram, is it?
She stopped at like, she just touched on conditional, like, you know, that formula you
Just now we
showed,
went through. Just
the
now we
one
went
with
through already.
yeah, that one.
Yeah. So that one you understood, right?
That was where she stopped.
That one you understood, right?
Yes.
Okay. So I think we will stop here first.
But I feel like I still need more practice, cause like
on conditional prob, is it?
yeah.
Okay,
Yeah.
later I send you some questions on conditional, maybe like just 3 to 4 questions on conditional prob.
Okay.
On WhatsApp.
Okay.
Through WhatsApp.
Yeah. Okay.
Then you practice and then you send it back to me.
Okay.
Can so I think we will stop here first. Then I will upload this onto YouTube.
Okay.
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 But
Thank you.
this is okay, right? You understood, right?
Yeah. Good.
Great. Okay. Bye bye.
Okay. Bye bye.